Hey guys, so we're going to stick with the same topic for another day. It's just going to be more practice of the same idea. We're solving logarithmic equations, but it's going to require the properties to do it. And then when we get at the bottom, there's going to be kind of a new thing that sort of appear a little bit new to us, but I don't think you'll find it terribly difficult. And there's only going to be one problem on this new thing, so hopefully you won't be bothered too much by it, and we can move ahead from there. So start with a problem like number 10. So again, it's a logarithmic equation. We want to solve for the variable x. We need some way to cancel out the log, but you can't do that unless you first condense this. So I'm going to condense using the quotient property. I'm going to make this into 1 log base 6. Remember that the minus sign sort of turns into a division bar, negative x on top, 10 on bottom, equals 1. So we condense the logarithmic expression on the left, and then we can do that process that I call dropping a base. Drop a base 6 here, it cancels out the logarithm. You get negative x over 10 equals 6 to the first power. 6 to the first power is still just 6. Now to isolate x, we can do a neat little trick here where we just multiply both sides by negative 10. Multiplying by 10 cancels out the division by 10, and then the two negatives cancel each other out, and you get x equals negative 60, and that should be the answer. Remember, you are supposed to check yourself on the calculator. Yesterday I told you don't worry about it. I'm going to go ahead and do that now. So into this equation, I'm going to plug negative 60. You see I have, You see I have two negative signs there. There's a negative sign here, and then the 60 itself is negative. And then minus log base 6 of 10, and we get 1. That is the right answer, so that means that negative 60 is correct. Of course, I'll scroll down and check it anyway, but there it is. So, just like yesterday, there's nothing new here on number 2. Number 4. Very similar. We have a minus here, so I can do the quotient property. Log base 7 of x squared plus 5 over 3 equals 42. Oh, nope, sorry, equals log base 7 of 42. The logs cross each other out. This is a 1-to-1 property. X squared plus 5 over 3 equals 42. I can multiply both sides by 3. X squared plus 5 equals, well, I don't know, 42 times 3, 126. Subtract 5 on both sides. I'm running out of room. Let me come up here. You do it with x squared equals 121. Square root both sides. Remember, whenever you use a square root to solve an equation, you have to put in a plus minus. And the square root of 121 is 11. So our answer should be positive 11 and negative 11. If I'm going to check this on the calculator, function log 7 11 squared plus 5 minus log base 7 of 3. Now that's supposed to equal the other side of the equal sign, so let me type that in on a new line. Log base 7 of 42. And you see something's wrong. Oh, duh. See that right there? That's a plus 5. That was supposed to be a plus 5. Okay, now they both match, 1.92. So 11 is a good answer. Now I'm supposed to check and see if negative 11 is a good answer. All I have to do is change that to a negative, and the answers remain the same. So positive and negative 11 are both right answers. Let me go down to number 4. There it is. So number 4, also just like yesterday, except we had to do this little square root step here. So the only thing is, when you square root, you put a plus minus on your answer, and then you're supposed to check both answers. Remember, we have this thing called extraneous solutions. Sometimes you plug in a number, it does not work, and so you're supposed to know to fix that. Let's look at number 6. So another quotient property. I bet I meant this to be a product property, and I slipped up when I made the worksheet, but we'll just deal with it. So x plus 1 over x equals 4. Again, the quotient turns, the minus sign turns into a division. That's called the quotient property. Drop a base 2 here. We get x plus 1 over x equals 2 to the 4th power. That's 16. Now, how do we solve this? Multiply both sides by x to cancel that out. X plus 1 equals 16x minus x. Let me come up here. 1 equals 15x. Divide by 15. You can't really divide 1 by 15 without getting a decimal, so we'll leave the answer as a fraction. And okay, let me save time. I'm sure you get the whole idea here with me typing in the answers in the calculator to check it. Let me just go down 1/15 right there. Okay, number 8. Here we go. Now we've got a product. I'll go ahead and write that down. I'm going to use the product property here to condense, and it's going to be x times x plus 16 equals log base 6 of 57. We are able to cancel out logarithms on both sides, and so they're gone. I'm going to go ahead and distribute this, get x squared plus 16x equals 57. Now a quadratic like this, we're going to need to have one side equal to 0. So I'm going to bring the 57 over to the other side. That'll make it a, what was that? That'll make it a negative 57. So it's positive over here. When you bring it over, you just subtract it. And now we need to factor this. 57 is a weird number. Let's see, what's 57 divisible by? It is divisible by 3. In fact, 3 times 9 is 57. And it just so happens you can do something with a 3 and a 9 to get a 16. If I had a, 3 and a 19 to get a 16. If I had a positive 19 and a minus 3, that would do the trick. Now I'm running myself out of room again, so I'll come up here. So you set x plus 19 equal to 0 and x minus 3 equal to 0. The first one, subtract 19 over, you get negative 19. This one, add 3 over, you get x equals 3. All right, I'm going to go back to the calculator. I'm going to check these. So, log A, I'm going to the original equation here. Base 6, I'm going to check negative 19. And I already get undefined. I get an error right off the bat. That is an extraneous solution. You just cross it out. Now let me try 3. Log base 6 of 3 plus log base 6 of 3 plus 16. Then the other side of the equal sign, log base 6 of 57. They equal each other, so 3 is a good answer. 3 is the only good answer for number 8. And there it is, just 3. So that negative 19 created an error. That means it was an extraneous solution. Okay, so more or less, this is all very much like, I spelled quotient wrong. This is all very much like what we've done. Some of it what we did yesterday, some of it what we did last week. And then some things are throwbacks to, what we talked about a long time ago, like whenever you square root both sides of an equal sign, put plus minus on your answer. Number 10 is kind of new, so we're dealing with a natural logarithm here. So we do need to condense this. We have a plus sign, so I can condense this into one logarithm using the product rule. So it's going to be 4x times 10 equals 5. Remember, pluses turns into times, minuses turn into divide. Now, how do we cancel out a logarithm? Well, if there's a logarithm on both sides, they cross each other out. If there's only a logarithm on one side, you have to drop a base. The base of ln is e. So you drop an e on both sides of the equal sign. That makes that cross out. That leaves us with 4x times 10. Well, that's 40x. You can do that. Equals e to the 5th power. At this point, you have two options. You can do e to the 5th power on a calculator and round it off, or you can just leave it as e to the 5th power. The directions here say to find, it doesn't really specify. All right, I am specifying to you to leave it as e. This is called finding an exact answer. When you use a calculator and round it off, you're finding an approximate answer. To solve for x here, I would just divide both sides by 40. Get x equals e to the 5th over 40 as your answer. So you're treating e like a variable instead of a number. There it is. And that's your answer. So when you do number 9, show your work, but I'm showing you right now, your answer is going to have e in it. Okay, so just treat it like a variable. When you get to the point where you drop your base, you drop your e, and then from that point on, you just pretend it's a variable instead of a number. Don't do a calculator approximation. Okay, so number 10 should help you a lot with number 9. Number 8 should help you a lot with number 7. Number 6, unfortunately, like I said before, I think I meant that to be a plus, so it would kind of match this problem. So it turns out 6 is not really going to help you out with 5. You're going to have to kind of work that one on your own. But, oh wow, same thing for number 4. Ugh. Well, not a perfect assignment. 4 and 1, 6 and 1, 2 and 1, those are all quotients. Those can all kind of help you out with 1. When you get to 2 and 3, when you get to 3 and 5, just make sure you use the product property. Okay, and I'll leave it at that. Contact me if you have any questions, and then tomorrow, Wednesday, remember, if you read my announcement, I'm not going to be teaching anything new on Wednesdays. Wednesdays, I'm just going to kind of hang out and be there to help you from 9 until noon. If you're not available during those times, just drop me an email. We can try to schedule something, but I'll be able to jump right online anytime between 9 and noon on Wednesday. So give this your best shot. Check your answers. Show your work. Don't forget to show your work. Turn it in and contact me with questions.